All right, stat students. So I'm making this video as a brief review and summary of the confidence interval section. The idea is that you guys are going to take your test. It should be today. But like a lot of my in-person students, they wanted a brief review and a summary of this unit. I do apologize for the clunkiness that's kind of been Delta Math. The idea and the theory was that it was going to be a very beneficial thing that you can do all your work and it gets checked immediately and you know if you did it right or wrong, okay? And I think that's been an additional struggle for the AP students. I appreciate all y'all's hard work on trying to get your answers, okay? But what we're going to do is I'm going to work 3 questions from the confidence intervals worksheet 3. Obviously I've got the two, there's a dual credit version and an AP version. So I'm going to be look at the top of the screen here. When I'm working at state dual credit, now if you want to watch to see how both are done, that's fine. Dual credit, you get to use your calculator functions more. AP, I'll have that up on the top of the screen. If you just want to skip through, like since this is just going to be a YouTube video, you can sort of, I don't know what the word is, squib through it, I don't know, and find at the top when I'm working an AP problem or I'm working a dual credit problem, okay? With that being said, we're going to start by talking about the dual credit. We're going to worksheet 3, which I'm not sure that everybody's done that yet, but we're going to start here. A hardware manufacturer produces bolts to assemble various machines. Assume that the diameter of the bolts produced by this manufacturer has an unknown population mean mu, and the standard deviation is 0.1. Suppose the average diameter of a simple random sample of 50 bolts is 5.11. Okay, so I'm actually going to read the intro for each question with each class in each part, and then I'm going to do the solutions for each one. Okay, so first thing it says, we need to calculate the margin of error for a confidence interval for mu. Do not round until the final answer, then round to 4 places. And then we have to figure out this, what is the width of a 95% confidence interval? So these questions are very similar. So we're going to talk about how to work each. AP students, make sure that you have your formula sheet up. You know how important that's been in working a lot of these problems. I would actually go ahead and ask dual credit to do the same thing. Your formula sheet is very helpful in a lot of these problems. So give me 1 second to pull that up as well. Okay, so we have the formula sheets ready to go. Now for dual credit students, this I'm starting with y'all right now. So AP students, if you want to skip ahead, you can. These are the formulas that we need here. This is your margin of error, okay? That's what all these formulas are, margin of error, okay? So we have to figure out which one we need. Here's proportions, here's means. So we go back to Delta Math, and you'll notice that we see the word mean here, mu, okay? And it gives us a standard deviation. So we know that we should be using one of these formulas. Do we know sigma or do we not know sigma? Well, we have to look at the standard deviation. How does this read? It says, assume that the diameter of bolts produced by this manufacturer has an unknown population mean and the standard. So this is reading as if this is the population standard deviation. So we do know sigma. So we're going to be using this formula right here. And it's just these 2 parts. That's all we need. That's all that we need right here are these 2 parts. So your error, your margin of error, is equal to critical value, which is what this is. I know a lot of students have gotten confused about this, but remember we wrote out, actually no, I think that was the video that got missed and I posted late. I'm so sorry about that, by the way. This chapter 8's kind of been a little bit of a mess on my end. I definitely apologize about that. But these values, this Z sub alpha over 2 for dual credit, now AP students, if y'all are still watching, we have a different way to do this, but it's either going to be a 1, a 2, or a 3, okay? So because we're 95% confident is what we want, it's going to be a 2. Okay, so really this is going to be a 2. We know sigma and we know n. So we're going to be using this formula here. So in our calculators, so I'm going to pull up my other display here. You go ahead and have your calculator open. We need to do 2, which is that Z sub alpha over 2. That's all that is. Times, we're going to make a fraction, control divide. We want sigma, which is 0.1, over square root n, which is n is 50. Okay, so that's what we end up getting, this 0.028. We're gonna have to round that up right there. So I'm gonna go ahead and type that in while y'all can still see it, 283, okay? So we go back over main display here. So this is what you should have in. All right, so that's our margin of error. So it says, what is the width of a 95% confidence interval for mu? Do not round to the final answer. Okay. So what is the width? So we have this margin of error, and how do we construct an interval? Well, we can create the interval by adding that error and then or subtracting that error. That gets the lower and upper boundary. That's what we've been doing for all the practice sheets that we've had. So when we talk about the width, we're actually talking about the total distance from the lower to the upper. Okay? So what is the width? It's upper minus lower. Well, there's another way that we can think about this. It's actually going to be double our margin of error, right? Because we're taking that point estimate, that 5.11, we're adding that 0.0283, and then we're subtracting that 0.0283. Double this. It's double this value. So let's go back over to our calculator. And I'm just going to go times 2. And this answer needs to go in. So I'm going to round that now since it's the final answer, 566. Put that in here. We're going to go ahead and submit. Okay, and we got that right. Okay, let's talk about AP. So AP students, let's look at your example here. All right, so you've noticed with the formula sheet that 95% confidence for these for intervals that are this would be a Z interval, right? This is not a T interval. Even though we have a sample of size 50, since we know sigma, it's got to be a Z interval. So going to this table down here, we would not be using degrees of freedom on the left side. We would not be using this column, okay? We have to go with the infinite. We're using a normal curve, okay? So we're actually going to use 1.96. We don't actually use 2, okay? So 1.96 is what we're going to need. Now you have your formula sheet up here that all it really shows for these confidence intervals, this right here, critical value statistic plus critical value times standard error statistic. This is what we need, okay? This is your margin of error on the right side. So we need our critical value, which is 1.96. Let me go over to my calculator here. So 1.96 times, what is the standard error of the statistic? Well, it's sigma over square root n. I'll even pull that back up on here because we know sigma. Here it is right here. That's the formula we want. Here it is. If we didn't know sigma, we'd have S, right? Standard error right there. We need sigma over here. We're going to do 0.1 over square root 50. All right. So that's what we get. So type that in, 0.02. And that's it. So it's to 4 places, 0.0277. So if you are AP or dual credit and you're still watching, this has been the struggle, is that I made the dual credit one first, and I've had to convert these because the way that we're doing some of these calculations are not exactly the same. However, B is going to be the same process. So we talked about, if you skipped ahead to now, the width of your confidence interval is the distance from the point estimate when we add this value. Oh wait, I need to change screen. So here's what should be in here, right? Width is the distance from the lower to the upper boundary, which should be double this, right? Because we add to get up, we subtract to get down, combined, right? It's double this. So going back, we're going to multiply our answer by 2. This is what should go in there, 0.0554. Go ahead and make sure you type that in. And this is what you should have here. There we go. Okay. So a good question to prep for the test. Majority of the test questions are going to be asking you to construct confidence intervals, but this is good. One of those, like a single question could be, okay, find just the margin of error, right? We haven't had a ton of practice with that. But let's go ahead and go on to the next question. So all students should be watching now. I'll put dual credit here to make them pause it. But let's look at the next question. So here I think we're doing intervals. Let me back up. Okay. So you want to rent an unfurnished 1-bedroom apartment in Boston next year. The mean monthly rent for a simple random sample of 32 apartments advertised in the local newspaper is $1,400. Assume that the standard deviation is known to be 220. By the way, since we don't have any of the checks here, we're just going to assume that everything is normal and it's, less than 10%. All the conditions have been met. We're just trying to practice a little bit more here with this. Furthermore, we have to answer this question. It's a concept. Does the confidence interval give us information about a statistic or a parameter? We have all these questions about how percent and your confidence and sample size, how to interpret them, and all of that. Okay. So let's go ahead. I'm going to start with dual credit. AP students, if you want to skip ahead, you can. But dual credit, let's talk about how you guys want to do this. As soon as you see this question, find the interval. Right away, you guys need to grab your calculator. You need to decide, is it menu 6, 6, 1, 2, or 5? Because those are the options that you have when you're constructing these. And even if it's an interval that that you can make 68, 95, 99, 7, you should just go ahead and have the calculator do it for you. Okay. So, is this X bar or P hat? Well, we know it's X bar because mean, right? So then we need to decide, do we know the standard deviation? Do we know sigma or do we not know sigma? So sigma, look here, it says assume that the standard deviation is known to be 220. Whenever you see it phrased like that, that is an indicator that this would be for the population, right? This isn't talking about the sample. If this period wasn't here, then we would say, okay, that would be part of that sample, right? But this is going to be sigma. So when we go to our calculator, we're going to do menu 6, 6. It's a Z interval, right? Because we know sigma. We have the stats. We don't have any data. So we're going to go stats, and we have to type all this in. Okay, so looking at this question, we know what sigma is. It's 220. X is 1,400. That's the mean of those 32 apartments. 32 is the sample size. And then we want to be 99% confident. 0.99. Okay, so we've got that. Here's our interval. It says to the nearest cent. So really, I'm just going to type in these values. So we get 1299.82. Okay. So let me show what I have. This is what I have typed in. Okay. So then we see this next question. Does the confidence interval give us information about it, the statistic or the parameter? The answer is parameter. Statistic would be this 1,400, right? We don't need information about that. We know what it is. These intervals, the whole point of them is to make an estimate for the population parameter. We want to know that value, the population mean, right? So that is the parameter. That every interval, that's what it's trying to do. It's trying to guess. Okay, that's what it's doing. Okay, now I kind of have to zoom out a little bit on this one. All right, how do we interpret 99% confidence level? I'm going to go ahead and give you my personal guarantee that you will have a question like this on the test that you're going to take. You have to know all the questions that we've answered on the practice before this. At the end, I had you interpret, right? We are blank percent confident. Now that is interpreting a confidence interval, but how do we interpret the confidence level? It's different, okay? Confidence level, we have these 4 options here. And the best choice is C. And this is, from your notes, the definition of confidence level and how we interpret it. We wrote it down. 99% of the intervals constructed using this process that we used up here to create this one, based on sample sized same size samples from this population will include the population mean. There's not, it says 99% of this possible population means will be included. No. There's only one population mean, okay? We're not interested in samples. That's not what the sample means, okay? We're not interested in including the sample mean. It has to include the sample mean because that's what we're using to construct it. It is C. That's the best choice, okay? Next, what if the sample size was 40 for the 99% confidence interval? So it was 32. What if it was 40? How would the confidence interval change with this larger sample size? So I believe we listed out properties and we said, okay, how does increasing or decreasing sample size affect your interval, right? And that was on worksheet 1. We talked about the changing of the different parts of your equation. That was also on worksheet 2. So every worksheet has been asking these questions, and it's very important that you understand how these are changed by sample size. So when we increase sample size, what ends up happening? Well, the interval would have the same center, so we know it's going to be C or D. Would it be wider or narrower? When you increase the sample size, it gets smaller. I had the simulation on the screen that one day where we worked, or where we saw the different behaviors for when we change those things, okay? So these are all the answers you should have, and you should get that correct, okay? So now I'm going to switch it to AP. So credit students, y'all can skip ahead. So AP students. All right, here we go, AP students. We are going to be talking about this question. I'll give you all a chance to find us and pause. So we're trying to find our confidence interval here, okay? Now, when we read this, it says, assume the standard deviation is known to be 220. This is an X bar situation, right? Because we see mean. But assume that the standard deviation is known to be 220. Okay, when you read that and you got this period here, this is telling us that it's going to be sigma. So this is going to be a Z interval, all right? And we want 99% confidence. So when we go to our formula sheet and we look at our T distribution table, we know that we need to be using this last column here. So this is going to be our critical value. That's going to be that, okay? And then we're also using the our standard error is going to include sigma here. Okay, so here's our point estimate. We have our critical value, 2.567, and then we're going to create our standard error. Okay, so let's go ahead and do that. So our point estimate was that 1400. And for me, I always do the addition first. I don't know why. I'll do subtraction first this time. All right, minus 2. Let's look at that. 2.576. And we want to multiply by the fraction. We want 220 was our sigma, right? Yep. At the bottom square root, we had 32 apartments. The lower boundary. And then, I don't know if you've been doing this, but you can go up and copy. I like to do it that way so I don't have to rewrite, and I just change this to a plus sign. There is no plus or minus, I don't think, on these Inspires. I haven't found them yet if they do exist, but these should be the answers that you get, and this should be your interval. Now that actually ended up being the same as the dual credit one that they had up there, but you still want to make sure that you use this process to get those. So let's go back here to our display. All right, so that's what should be in there. It says round to the nearest cent, so that worked out fine for us. All right, so the rest of these are going to be sort of concepts and little definitions that you need to know, okay? Does the confidence interval give us information about the statistic or the parameter? Well, statistic we already know. We didn't need information about it. The statistic is 1400. That's X bar, right? That's our point estimate. Confidence intervals always tell us information about the parameter, okay? Always, okay? Next, we wrote down 2 quotes, if you will, in our notes. One of them was for confidence interval, and we've been using that one on all of these tests, or all these worksheets. Worksheet 1, Worksheet 2, you had to interpret what the confidence interval, and we would say we are 99% confident that the interval from blank to blank captures the true mean apartment cost. That's what we would do here, but I didn't put that in here. We want to interpret confidence level, okay? Different, and if you look in your notes, you will see that. And I'm going to go ahead and give you my personal stamp of guarantee that there will be a question that says interpret confidence level. It's different than confidence interval. Confidence level is saying if we took many samples of the same size, 32 like we did up here, okay, 32, and did the same process that we did over here, right, through all of this, right, then we would 99% of the time we would get our population parameter. It would be somewhere in here. It would capture it. So when we look at this, the answer that's the best choice would be the C. 99% of the intervals constructed using this process based on same size samples from this population will include the population mean. Okay, so that's what would be the best choice there. All right, you need to be looking for the word confidence level on the test. Okay. Next concept question. What if the sample size was 40 instead of 32? How does that change this interval? Right? You don't have to do any calculations for this. If you want to, you can go back over here and just copy and paste and redo this with 40. But I really want you guys to think about this. What's going to happen? We've talked about it. When you increase the sample size, what happens? Well, the center would not be shifted, by the way. You would not be shifting the interval left or right. You would still have it centered around 1400, okay? But it would be narrower because we're dividing by more in our fraction, okay? So these should be all the correct answers for this problem. Okay, there we go. All right, let's get everybody back on here. Everybody back. Let's talk about question number 3. Okay. So let's read the scenario. Let's talk about everything happening here before we split the video up. It says the New York Times and CBS News conducted a nationwide poll of 1,048 randomly selected. I don't know why this said 30 to 17. I think it should be, I'm not sure. 13, I'm not sure. Whatever. Don't worry about it. It's not that big of a deal. We can consider this to be an SRS. Okay, so we're not doing any of the checks, but when we read this, let's read the first part. Of these 1,048 teenagers, 692 had television in their room. Give a 95% confidence interval for the proportion. Ooh, we see that word there, proportion, right? So this is making us think p-hat. Proportion of all people in this age group who had a TV in their room at the time of the poll. Do not round to the final answer. Okay, so right away, let's go ahead and talk about this proportions. Let's do dual credit students. So we're just talking to y'all. As soon as you see proportions, automatically in your calculator, there is really only one. There's one option, and it's this one, number 5, right? One proportion Z interval. That's all we need. So we're going to go ahead and click that and just have that ready if it's telling us to create an interval. So it says of the 1,048, 692 had television in the room. So we're making a 95% interval for that. Okay. So successes would be the number that had them in the room, so 692. N is the total sample, so 1,048. And then we want to be 95% confident. It's already ready. We just hit OK, and we get our answer right here. So I'm going to go ahead and type that in. 0.6316, 0.68. That's going to round up to 689. Okay, so here's what I have in my answer key, or in my answers here. Okay, let's look at B. This one's going to be similar. It says they're interested in their favorite television network. And so but it says 189 named Fox is their favorite television network. We want a 90% confidence interval for the population of all people in the age group that would choose Fox. This is still proportions. Back over here, 6, 6, we want another Z interval. So now we're just interested in a lower proportion, 189 out of 1,048, and we change our confidence level to 0.90 and hit OK, and we're just going to type those in. That's our new interval. Okay, and it rounds to 1999 for the upper interval. So let's go back to the display. That's what I have. By the way, this is the last problem for dual credit. So after I finish this, you can stop the video and take your test. But it says, suppose you were to change the confidence level in B to 95% using the same sample. How would the confidence interval change? So you don't need any calculations, okay? So we're going from 90% to 95%. Now, if you wanted to calculate this, type this in your calculator, you could, and you can see the change, but we don't have to. We should know the concept of increasing confidence level. What does that do to the interval? We've written that down. Which one is it? Well, that doesn't shift anything. It doesn't change our point estimate. It's still whatever we got. It was 0.1803. Okay. But it is going to change that margin of error. It's either going to increase it or decreasing. Well, by increasing the confidence level, that increases our critical value, which increases our margin of error. Really what that does is it widens. Okay, it's going to widen the interval. Okay, that's what that's going to do. All right, we submit that and we get it correct. Okay, so dual credit students, y'all can go ahead and stop the video here because the last part's just going to be AP. That was my last question. Oh, I did want to say one more thing. A lot of the questions are going to ask for point estimate and margin of error. Format is going to be a little bit different of a format. This is going to be that point estimate and margin of error. Sometimes obviously you know how to get the intervals, which is what I've done most of my problems with. But if it's in that plus or minus format, you can just use these parts right here. Okay, that's fine. Okay, so dual credit students, you can go take your test now. You should be in good shape. AP students, let's finish this video up. We're talking about a problem that is dealing with proportions. Okay, so if we needed a little more practice with proportions here, we're getting it now. Let's first. We know that we need the point estimate. Okay, so to get our point estimate, we have to do the division here. 692 divided by 1048. So I'm going to do that over here on the left. So I'm going to do 692 divided by 1048. By the way, I know when I hit enter, it's not going to give me a decimal. If you want a decimal when you type it in, there's a couple ways to do it, but the easiest way is to just put a decimal point and it'll give it to you, okay? Now remember, you don't want to round until the final answer, but this here is our point estimate, okay? And we know to that we have to subtract the margin of error and we have to add. So I'm going to go up, highlight, and subtract. And we're going to start with our critical value. So what is the critical value for a 95% confidence? This is proportion, so it's a Z interval. 95%, infinite degrees of freedom. So it's this one here, 1.96. We discussed that earlier. So I'm going to go back and we do 1.6 times. We're going to go ahead and for standard error of proportions, we have this right here. This is what we need, p hat over 1 minus p hat. So again, I'll show you some other good ways to use your calculator to help you out. Let's go ahead and make our radical, and then make our square root. We can go up from here. If we're inside of this space here, notice how I'm going between these spaces. If I start here and I go up, I can hit enter and it just copies it in. And then I can do a parentheses 1 minus, go back up, copy it again, right? That's how we're making sure we're getting exact. And then what's our sample size? 1048, right? And this is going to be extremely exact, and we're going to hit enter. This is the minus version, right? So that should be correct. All right. And then we're going to go back up, and we're going to do the plus version. I hit enter, go all the way back, and change it to a plus. That should be the upper boundary. So let's go ahead and type those values in. So I should get 0.6316 and 0.68. I'll round up to 689. Yes, that's how we create that interval. And then we see this new problem. where we change the proportion. It says we're interested in the proportion who like Fox network. And so this is going to change our proportion. We have to really do some recalculating. So we have to find our new critical value. So let's start by finding that new critical value for 90%. We'll scroll back down. 90% is 1.645. Okay, so let's do some calculating over on the left here on the calculator. First, we're going to do that 189 divided by 1048. Make it a decimal. So there's our new proportion. That's our new point estimate. We want to subtract this critical value. I said that was 1.645. And we want to multiply that by, we put our radical, our root. We're going to copy in that proportion that we have above times the complement of it, p hat times q hat, over 1.48 or 1048. There's our lower. Copy that back down. Again, the copy and paste feature, super helpful. And there's our interval. So I'll type this in. We're going to round these to 4 places. So it's going to be 1608 and 0.1999. Yeah, 4 places there. So let's go back. What we should have for our answer for the proportions. Then what's going to happen, and so we don't have to calculate anything here. Suppose you were to change the confidence level to 95% using the same sample. How would the confidence interval change? Now, if you wanted to recalculate it, you could to get your answer. But theory behind the percents, we know that that's going to change the critical value. I think AP knows that better than anybody, that's just going to change what happens on that table, right? And that value will go up if we change it from 90 to 95%, which is going to make our interval wider, okay? It doesn't shift it, but it will make it wider. So we're going to submit, and that will be correct, okay? All right, so we're going to stop there. You should be prepared to take the test now. AP students, you will have your free response, which will be on Kitum, so make sure that you get that done as well. And good luck on the test. I'm going to go ahead and stop the video.